start this one, and then we'll start the one behind you.
Well, welcome to Tech Saturday, December 2022. What we're going to talk about is basically CAD design tools. We were going to talk about just 3D printing, but like I talked about on Wednesday night, bringing a 3D printer in and watching it print, it's like watching paint dry. So there was kind of no point to that. So I'm going to go through SketchUp, through Fusion 360, which is what I use to build some stuff. And then hopefully Frank will get here and he's going to talk about SketchUp. Frank did the design for that room and this area out here in SketchUp, and it's very detailed. John and I have been looking at it for months. And it lets him do things like make sure there's room for stuff. You don't have interference between two different, things like that. And then Carl, again, if he gets here, works with AutoCAD in his job and is going to talk about that. So hopefully all of that will happen and those guys will get here. So the thing that I made is this little box. I built this yesterday, and I built it to hold an Arduino Uno. Okay, that's an Arduino Uno. Okay, a little microcontroller. Right, everybody's probably seen what an Arduino looks like. And I just built a box to hold the Arduino. So I'll pass this around, but basically it's just a box, and it's got little mounting holes in it with a hole that are underneath the Arduinos, and it's got two cutouts on the side for the power connector and for the USB connector on the Arduino. And then I made a cover for it that fits on the top. So when you put the Arduino in the box and you put the cover on it, that cover fits so tightly that it doesn't fall off. Nice. So, I'll take this and I'll pass it around if anybody wants to take a look at it.
This is Fusion 360.
This is Fusion 360. So Fusion 360 is, I know about 3% of what Fusion 360 can do. I don't know what anything from like here over does, but what I understand that it can do is it could, like, you could model a beam, and then you could model putting a weight on the beam and tell it what the beam's made of, and it'll tell you the torque on the beam and the stress and whether the beam's going to bend and stuff like that. So all the stuff that we took in mechanical engineering courses and strength of materials courses and all that kind of stuff, you now do in the computer.
Is this the hobby version?
There are two versions of it. Yeah, thank you for bringing that up. There is the paid version, which is $495 a year. There is also the free version, which if you go to the website, it will tell you which features it does not have. I'm guessing it's the same software. It just turns off those features based on who you log in as. And I went in and originally when I did this, it looked like I was on a 30-day trial. So I went in and logged in and registered myself as the personal user. And then now it's telling me up here, personal, not for commercial use. Okay, so apparently I have a restricted version of this thing, but it hasn't restricted anything that I needed to make that. So there are two components to this thing. One is the box, and the other is the lid. And I should have, when I created my device here, I should have gone and done a new component for the box, but I didn't do that. But I did do that for the lid. So the box is now lit. I could light the lid, turn the lid on by clicking this little button here. I think by not having a separate component for the box, this is turning everything on. So I did make a mistake in doing that. Yeah, Ron. Oh, you want to see it? Yeah, take the top off too. So one of the cool things about working with Fusion is this is the steps for building it. If anybody's worked with Lightroom, this is kind of like that, because in Lightroom you put the little steps that you're taking to process a picture, and this is the individual steps.
Like layers in Photoshop?
I kind of, maybe, sort of, maybe not.
Okay.
This is actually each operation that you've done. If you drew a rectangle, or let me back up. If you did the sketch, one frame there would be the sketch. If you then took that sketch and extruded it, that would be the next frame, the extrusion. If you then took that and put holes in it, that would be the next frame. Would be
I'm kind of
each
getting ready to
operation
show
that
that.
you did is a separate frame in that timeline.
Gotcha.
So let
Okay.
me show you what I was talking about here. So I'm going to go back to the first step here, and I can do edit sketch, and that starts. Oh, and I bought this thing years ago. I have no idea what I bought it for. Okay, but I plugged it in, and it lets me do stuff like this. And I have no idea how to move things around like that without a device like this. I'm sure there's a way, but I've never figured it out. But
What is
anyhow,
it?
having this, it was called a Space Commander 3D connection.
Huh.
So, but anyhow, that's how I'm moving this thing around. And so what I started with was, like I talked about on Wednesday night, a two-dimensional design. And I said, first thing I started with was this, okay, which is a diagram I downloaded of the dimensions of an Arduino. Okay, so that gave me all of where my holes are and what the size of the thing is and all of that kind of stuff. What it didn't give me was the dimensions of the USB port and the power port. So for that, I used this, which you need one of if you're going to do any kind of 3D modeling, basically a digital caliper. Measures the outside, measures the inside. And I had to write them on the diagram so I knew what the heck I was modeling. All right, so that was kind of the starting point. And so I made it a little bit bigger than the dimensions of the Arduino, because I want to have a little bit of room inside the box. That's why it rattles around just a tiny little bit. I think I put a millimeter on each side of it. So I drew a rectangle like I showed you the other night in at the meeting, and I said make it 72 millimeters by 57 millimeters. All right, so now I've got this inner rectangle. Then there's a function called offset, where I said I selected the inner rectangle, and I said give me an offset 2 millimeters more than that. So that drew the outer rectangle, and what's that 2 millimeters is the side of the box. So that 2 millimeters basically becomes this dimension right there. Exactly. Okay. And I think that's all I did right there. Then the next step was to extrude it. It's basically a push-pull. And I said, bring it out 20 millimeters. And that's basically taking that little rectangle and making it 20 millimeters high. Okay, so now I've got a square that's 20 millimeters high, nothing in the middle yet. All right, I've only got that square rectangle around there. Okay, so that's that step. The next step is I've got the bottom. Okay, the bottom was a two-dimensional rectangle. And I said, bring it out 2 millimeters. So now I've got a 2 millimeter thick bottom. Okay, so what I have now is basically the outline of a box. These cutouts are not here yet. The mounting points are not here yet. I basically have a four-sided box. That's where we are now. Then the next thing.
Hey, John.
Yeah.
Grab that and rotate that
not-
so they can see the 3D aspect of it, so I understand what you've got.
It's just stuck in 2D mode? Oh, there you go.
No, I can rotate it. Yeah, now I've already clicked over to the third piece of it so you can see the holes, but that's what I was getting ready to show you. Yeah, let me see if I can get this thing back.
Oh, excuse me. Click on the little square, click on like front,
Oh, there you go.
Yeah.
or if you click home, that'll take you to the,
Right? Yeah. This is great
and
news.
then you click top. Yeah.
There's always somebody who knows more than I do, which is kind of scary, but also really good. All right, so this is the next thing. All right, now I got to have the mounting holes. All right, so again, what I'm doing is I'm putting in circles I haven't yet made cylinders yet. I'm just putting in circles. So I decided I wanted a 4 mm wide post so I can put a 2 mm wide hole in it that I think will fit a number 8 screw or something like that. I wasn't concerned about that for this. So I basically put 3 holes in here, and I just dropped them in here because it doesn't matter where I drop them, because I can use this dimension thing here to say, I want this distance here between this and this line to be this distance. Okay, so I want this to be 6 mm because that's where, how far this hole is from this edge of the Arduino. All right, and I got that from the diagram, but I also could have measured from my caliper. And this hole is 36 mm and this hole is 7 mm because this hole is 7 and that's 36. Okay, so that's how I measured them, and I used this tool to place them. I didn't have to place them myself. Okay, and I also knew that this hole is 15 mm in from the edge, and this one is whatever distance that is, because I've also got this distance here set. Okay, so I've got the distance from the bottom and the distance from the edge. I've fully constrained where that thing is. So that was that step. And then I extruded them out 3 mm. So now I took a circle and I made it a cylinder. I made it a 3 mm high cylinder. There's no hole in it yet. It's now a cylinder with no hole. Where was I? So now, wait, it's maybe not here. Am I here? So now I drew another circle inside the first circle. See if I can blow this up. Yeah. So in each of the 4 mm circles, I drew a 2 mm circle. All right. That's what I'm doing there. And what I'm going to do next is I'm going to extrude them down. Okay, extruding up creates material. Extruding them down deletes material. So that's going to make a 2 mm hole in that cylinder that's 4 mm high, and it's going to give me the hole that I can run the screw in. Okay. And that's probably what I'm doing here. Yep, edit feature. And right here you see minus 2 mm. That's taking 2 mm out of that 4 mm post. Okay, so now that's how I have a post with a hole in it that I can put a screw in to hold that Arduino down.
Now, another way to do that same thing would be to make the first circle, then do an offset of 1 mm inside.
You do that.
And then extrude the 2 of them together, and that builds up a post with a hole in it.
You could do that for the whole box.
Right. Right.
Is there a feature to align shapes?
I'm sure there is, but I don't know what it is.
Okay. There's constraints, right? Like you can build constraints.
Yeah. So right. I thank you for bringing that up. So that's kind of what I was doing here. Where was the one where I had the holes? This is what you're talking about. Okay. This will be 15 mm. If I move this wall over, this will still be 15 mm. All right. And there's one other one that I'll show you about that's useful. If I made this, I told this to be a 2 mm offset. If I make the underlying box bigger, it'll still be 2 mm bigger. As opposed to if I drew 2 rectangles and made the first rectangle be 2 mm bigger than the other one.
Okay,
then if I take the bottom and make it bigger, the top's not going to change. So by using the constraints that he was mentioning, the outer wall here is defined by the inner wall. Okay, it's not on its own. I talked about that last night. I don't think I used that in this design where I do use it in this design office, so I'll talk about that when I come up with the.
The constraints though kept the holes where they belong, regardless of where the
Yeah,
sides go.
yeah. So
Okay.
if I moved the this is the holes. This is the wrong one. Yeah. If for some reason I elongated the box, if I moved this wall over by 3 millimeters, this hole would move over by 3 millimeters because this has got to be 15. I told it it's got to be 15.
Okay.
So yeah, that's what you mean by constraints. And there's all sorts of other things you can do. The video mount I was watching for the last 2 days to remind myself how to do all this stuff talks a lot about parametric modeling, which is exactly what you're saying. So you're not just taking shapes and dropping them here. They know where they're supposed to be relative to other things. So if you change the design, they still change. I will talk about it now. The example that I gave before was when I wanted to drill a hole from one side of the box to the other side of the box. So if I wanted to drill a hole from here, if I wanted to drill a hole from this side to that side, which are two different objects, I can say drill a hole, but I wouldn't say drill a 2 millimeter hole because it's 2 millimeters thick. I can say drill a hole to here. And I click on this and I say to here. And that will drill a hole through the thickness of the bottom of the box, whatever the thickness of the bottom of that box ends up being. So if I decided this wasn't strong enough, and instead of a 2 millimeter sides, I needed 3 millimeter sides, that hole's now going to be 3 millimeters deep because I told it to go to the bottom of the box. Okay, that's the parametric modeling stuff. You can make things relative to other things. If I had just said drill a 2 millimeter hole through the bottom of this 2 millimeter box, and then I just made the base of it 3 millimeters, I'd have a 2 millimeter deep hole in a 3 millimeter deep thing, and it wouldn't go all the way through. So that's why they design stuff like that.
There is good videos out there to help.
Yeah, there's a guy named Lars Christensen, I think. He's the one I went through his first two videos on months ago, and then like yesterday, because I had to remind myself how to do some of this stuff because I haven't done any 3D modeling for a while.
Autodesk also has a full series of short, and I do mean short, 3, 5, 7 minute long series of videos on specific topics that you can pick and choose. So if you need to go back and refer to one specific thing, you go and get that video. Now, as you're using the various tools in Fusion 360, each time you click a new tool, a dialog box will usually open up on the right-hand side of the screen. In the bottom of that screen is going to be a link to help for that command,
Okay.
which will take you to
I see your drawing.
the help function, and you can get to your videos from there.
That was
So-
Autodesk.
Autodesk Fusion 360.
Yeah, here we are. So at this point, I've got the basics of the box done. I've got the everything done other than these cutouts, which I'd forgotten about at that point. Okay.
That's fun.
So the next thing I did was to do the lid. And the lid, I realized this from watching the video, which I should have done the first time. I created a new component. Okay, because this is a separate piece. Okay, it's not part of this box. It's a separate piece, but it's related to this box. And ultimately, what I wanted to do is use the dimensions of this to create the dimensions of this. So I wanted to have them both in the same drawing because there's a function that will let you do that. So now I've got a new component called the lid, and what I think I did for that, there's a function that I don't remember the name of. I'm sorry, I have to go back for it. Where I basically can we have one conversation, please? Where I can say project this to a new piece. So I was able to grab exactly what the dimensions were of this piece and project it onto the lid. I think that's what I'm doing there. So now I've got the lid, and I basically have this dimension, which is this edge of the lid, and I've got this dimension, which is this edge, the inner edge of the lid, because this thing, slides in, right? And I copied them from this.
Just the top dimensions?
Yeah,
Okay.
yeah. Well, what I did is I selected this face
Gotcha.
right here. Okay. I basically took the box, turned it on its top, so this part was facing me, and I said, select this edge, and then project this onto a new piece. And that's how I got those dimensions. So now I have a two-dimensional rendering of this thing. And what I've got to do is take the top of the lid and extrude it out to 2 millimeters, because I want that to be 2 millimeters thick. And the bottom of the lid and extrude it out to 4 millimeters, because I want it to stick into this thing by 2 millimeters. Okay. So that is probably my next thing.
The right set of glasses on.
That's interesting. I'm used to having to build an object and then remove from it, but you're just building layer upon layer.
You could do both.
Yeah.
You could do both.
Sounds
I mean,
like, sounds like you were in Tinkercad.
yeah.
Yes.
So what I might have done here, since I'm looking at this and I see a minus 2 millimeters here, is I also, as Mike was just saying, I could have made the outer edge 4 millimeters, and then taken this lip down 2 millimeters. And that might be actually what I'm doing here, because I see a minus 2 millimeters here. I don't remember exactly how I did it. All right.
We get the 17-inch screen.
And then what am I to next time? Next feature. Yeah, and then that's probably what I did. I probably took it down 2 millimeters and then up 4. And that's how I got the edge to be 2 millimeters lower than the middle of the thing, right? Everybody see that? Okay. So there's that. Then I'm going back to the case, and I had to do these cutouts.
John, before you move?
Yeah.
When you did the lid, you just did the projection, so you had the exact dimensions.
Yes.
You didn't make any adjustment for fit or anything like that.
No, I just assumed that it was going to work.
Wow.
Well,
Read that
well,
on.
okay, but it did. Okay.
Obviously.
This is why we all have a garbage bag next to our 3D printers of failed experiments.
Yeah.
Okay. And
Only we can recycle the filament.
to John's point, when I looked at that diagram and I put it up here, I had this hole down there because I looked at it backwards. I looked at the Arduino backwards. I had this hole down there. So there is one in my trash can that is like that. But all I had to do is go back to the sketch where I said make this hole 15 millimeters from the top and say make it 15 millimeters from the bottom. I just had to change that way back here someplace, and then I came way up here. I didn't have to change anything else because everything else automatically followed. I just changed the dimension of it way back here where I made that hole, and then I printed it, and then I got this. So you like when you make a mistake on step 3, you don't have to go fix steps 4, 5, through 15. They automatically fix themselves. Yeah. Yeah, you could do that. You could do that.
I'm not,
You can use mounting stuff too.
I'm not grasping one of the mechanics of the program. When you did the projection, like, did it create a new object somewhere on the canvas? How do you bring them together?
So I had done create a new component.
Okay.
All right. And that created a yet undefined component. All it knew it was not the same component as the box. And then if I remember right, I could still select the box because it was there. And I was on the new component, I said project and went back to the box, and I selected this edge.
Okay, so you're already on the new part, and
Yes,
then you refer back to
right.
that part.
I believe
Okay.
that's right. Okay, so I'm stealing a I'm
Parameter.
stealing a parameters or what word I'm looking for. I'm stealing a parameter from this thing for a new one, and that's why I went to Lars Christensen's video, because what he makes is an electrical fitting box that has a top to it, and he shows you how to project that. And a lot of the things that I've made have tops, and so I want to know how to get that exactly right. I don't want to have to be off. Now it shouldn't be off because you're typing in the measurements. I could have typed those measurements in, and unless I screwed it up, which is a distinct possibility, it would have been right.
So the parameter that you lock onto to create the other component, if you were to resize that parameter on the box, would it resize it in the component that you
Good
created?
question. My guess is no, but I don't know that.
Okay.
I don't know. That's a really good question.
What was the question?
The question is, once I've projected the parameter for this onto the lid, if I went back and changed the size of the box, if I moved this box out 2 inches, would it retroactively change the lid?
If the two objects are linked, then the answer is yes.
Okay, so it might.
So that's the question. So
Well,
is
I
it
don't know if
linked?
they are. I don't know. What is
Because
it?
if it's moving, if it's keeping the holes in the posts all in consideration, would it keep the lid itself because it was created from that parameter?
You have to understand the concept with the way Fusion 360 works. The idea is, for example, you could build an entire thingamajig that consists of 15 different parts, and all these parts have to interrelate. So as long as it knows that part A has to fit inside part B, if you change the size of part A to make it larger, the opening in part B where it goes is going to change as well because they are linked.
Yeah, it's going to have
So-
to take some experimentation.
In this case, when you project the size of the box to the lid, you're linking the box and the lid together.
Okay.
So if you change the size of the box, that projection changes with it.
Okay.
That projection is the linkage.
That's correct.
Okay.
Yeah, so we're assuming that's that way. So anyhow, where I was here is now I got to make these cutouts. And so with my calipers, I measured that the power port is 9 millimeters wide, and the USB connector is 12.5 millimeters wide. Sometimes the diagrams will show you that stuff. Other times they won't. And I also measured, and this is another thing I got wrong the first time, how far from the end are each of these things. And I stuck them, you can see right here, 9 millimeters from the edge, 7.5 millimeters from the edge. And now I have a two-dimensional object projected on a three-dimensional object. All this is a rectangle. This is not yet a cut. It's not yet a cut. I still have to tell it how deep to make this sucker. So that's one of the trickier things to remember is you can have two-dimensional objects and three-dimensional objects, and you got to remember that you got to make them all work together.
How did it know to offset from the bottom?
I haven't told it that yet.
Oh, okay. I
was going to ask a question about when you extruded the holes through the bottom, the difference you made was to the bottom, but it automatically made up for that going all the way through. Right?
The holes don't go all the way through.
Oh, you're not going. That's right. You just
Right. I made a 4 millimeter post with a 2 millimeter hole.
Okay.
But on this one, I think I can show you the point I was going to make. So where was I? I think I was here. Edit feature. Yeah. So I wanted these were defined from this plane here. Okay, from the top. Why am I glad I printed this box? They were defined from here. I've got to tell it how far down to go. So how far down do I want it to go? And what I did here, if you look carefully, this says to object. So it's not a measurement. This says to object. And what I did is then it wants you to select an object. And what I did is I selected this, the inside of the bottom. And that tells it, however much distance this is, bring it down to here. Okay. And that was really good because first, actually, I remember now I printed like 4 or 5 of these. The first one of these, I only made 15 millimeters, and the top wouldn't fit on over the posts on the Arduino. So I pushed it up to 20 millimeters. Well, if I had done these cuts as a measurement, they would have been 5 millimeters off the bottom of the box. but that automatically said, no, I've got to make these cuts longer because I told it to go here. So I gave it a relative measurement to another surface instead of a fixed measurement, and it automatically fixed itself. So that's this tricky thing here. It's two object, and then there's no offset from it. There's no taper or any of this stuff, and the operation is to cut. So it's not creating, it's taking away, and that's how I got this down like that. And then what else did we do? I think here we just had to, for some reason I lost my origin and I had to go back and do that. So I think that's what these last two things are.
Can you reset your point of origin?
You can, and
Can you
So-
move the object and say put the corner?
I think
Yes.
so.
Okay.
So what happened is at one point I lost where this thing was and I had to go grab it again. So I think these last two steps are just me fixing something that I had screwed up. So at this point, I've got this thing completely designed. The steps that I took then are file. What I did is go 3D print. And I guess I can do this piece of it here too, because this is all software. And it says, what do you want to print? Well, I'll select the body. Okay, that's the box. I want an STL file in millimeters. I'm going to send it to a 3D print utility, which is for me, the Prusa utility that creates a file for my Prusa printer.
Okay.
The slicer, right?
Yeah, for slicer.
Right. There could be other slicers. There are,
360 also has a slicer built into it, so you can print directly.
okay. I just wanted to
Has
use the
anybody
one.
used it? Have you?
I haven't. I just know it's there.
Okay.
So when you export that into Prusa, your slicer, you have to go into Prusa and process it, or does it go all the way through?
I
the
will show you because I just said to export it. It's going to take a second. So this is what I get. Okay, this is the Prusa slicer. And this little gadget works here too. Now that's going to work. Okay, it's not like the thing I was showing you on Wednesday night where I had flanges out where you'd be dropping the filament over air. Okay, so I didn't have to turn this around or anything like that. My next step, which I won't do, would be export to an SD card. Because with my printer, you basically put an SD card in here, you export the printer file, and then you stick the SD card into the printer and you print it. So you're not printing directly from your computer. And their argument for that is if your computer crashes or something, you're going to blow your print. Whereas this way, they're completely independent. You can have your computer go do something. The printer's not dependent on the load of the computer or any of that stuff. So I would write this thing to an SD card, take the SD card out, put it into my printer, go down through the menu and press print, and then it start heating up because it knows that I'm using PLA. So my printer knows that if you use PLA, the bed temperature has to be a certain thing, and the filament temperature has to be a certain thing. It knows all of that. So it would just go do it.
I have a slicer question for, just kind of a general question. So the dimensions on this box, they're fixed and, they're made for the Arduino board. But if you're going to print it in, say, like ABS, I believe that plastic can shrink after you print it, I think. Does the slicer actually take that into consideration and create the correct dimensions to account for the shrinkage?
Provided that you select the correct material in the slicer, yes, it compensates the G code. Because ultimately, what the slicer is putting out is plain text. It's readable, but it's a series of vectors and origins in just a text file. That's called G code, and G code is pretty much universal in the CAD industry. You could have a 5-axis CNC super milling machine or your garden variety Ender 3D all use the same G code. And what the slicer does is it compensates the head position to make up for the differences in material.
Okay.
However, like everything else, there's a but. a lot of the slicers have predefined, like mine, the slicer for my printer, likes, verbatim PLA. Well, I don't use verbatim. I buy eSun. What you really need to do to minimize the mistakes you make is you go to the manufacturer, whoever's PLA, whoever's filament you're using, go to their website, and it will give you the actual physical characteristics, temperatures, flow rates, things like that. You copy those into the slicer because the slicer will let you create a new material, and you put those factors in, and that dials out a lot of the mistakes that you can make when something doesn't quite fit right. Because I told it Village Plastics PLA, and now I've got some bargain basement I got off Amazon, and the parts don't fit quite right. But yeah, so the slicer will do that.
Okay.
John, when you were making the lid for that box, does the lid get compensated to be inside that? You put a lip on the lid, right? So it clicks on. Okay.
Mhm.
Did you do anything? Did you say make the lid that perimeter 2000 smaller than the lid so it definitely goes in, as opposed to the same size?
So what I did was, I created the lid component, which had no components to it. And then I selected this edge here,
Yeah.
and I said project it.
Okay.
So that gave me basically two rectangles.
Uh,
One is the outer rectangle, the other is the inner rectangle.
Okay.
So I had two rectangles that were the same dimension as this.
Okay.
So I took this size and projected it onto the new component, and that creates the lip. Because the lip is basically just a smaller rectangle inside a bigger rectangle.
Yeah, but my point is my question is you can't put a 1-inch peg in a 1-inch round hole. You can't make it perfect. You
For a
have to-
box, you can get away with that.
Yeah.
For this,
I did not tell it to create an offset.
I had to do that for this.
You could just you could create the two rectangles.
That's what happens when you do what I did.
Okay.
You
That's
created
0.1 millimeter. There's a 0.1 millimeter offset that I added
Nice.
for this
Make it fit.
because it needs a little
That's
play.
one filament length, right?
Yeah.
What I'm trying to do is get to the
You extrude a hole through the middle of this, and now you got a nice cable gland.
I play with that thing every day when I'm on conference calls. I take it on and I put it off.
Fidget toy.
Yeah, fidget spinner.
That's cool. I mean, did you do any post processing on this?
No.
Damn,
It was kind of snug when I first made it, and I've just started doing it a couple dozen times. It just kind of
that's nice.
Yeah,
died,
I was
it,
impressed
tap
that
and
well
died
it's got
itself.
dialed in.
Yeah.
What printer?
At the Inner 3.
Oh, nice. So you've spent a gazillion hours to fine tune your ender to get.
Not really.
No.
He does most of the work. Yeah. He might have, I didn't.
Okay.
He's got a guy.
Yeah.
You have people.
I have people, yeah.
I'm going to try one more here, and then I'm going to. What I'm trying to do is now do the lid,
I just email it to him.
and I'm trying to just select the two components of the lid, and I'm not doing it. But I did obviously get it for this. And I'm going to try one more time, and then give up. It's telling me I still only have one. The issue that I had with the lid was when I originally dumped it into the slicer, it was like this. Okay. Now I'm trying to print with over air.
No support.
That won't work. So let me go back to one of the earlier.
You can
slides.
do it a little bit, but you got to be really careful about the way you do it.
Yeah, and or you can put in this where it says supports. It'll add plastic
filaments
to support stuff, but then you got to clean them off, and you got to use an X-Acto knife, and it's a pain in the ass, and it takes a while.
Do you rotate? Would you rotate that in?
So what I did,
Yeah,
thank you,
okay,
that's
sorry.
exactly where I was going. Is I said just to make sure I was going in the right direction, I said rotate on the y-axis 90 degrees. Okay, now I am going the right direction. And I'm going to go another 90 degrees. And you can see how you basically take the thing and flip it over. And so I flipped it from this to this, and now it will print. And so my next thing there obviously would be to dump it onto the SD card. And
Are you doing that in your slicer or in your CAD program?
I did it in the slicer. You know, because when I looked at it on the platform of the slicer,
Mhm.
you know, and that's why when I was looking at the other ones where I didn't get it right, no, these are all the same way. Yeah, I was looking, so I zoomed way in, and I wanted to see if I had both edges here, which I don't.
Mhm.
You know, back here I would have had to click on. I wasn't able to click on both of these now, and I don't remember why. The other thing I'll show you, and then I'm done, is this is what I was showing you the other night, which is working with a STL file in other programs. So I'm going to export the case to case9.stl. Do you want to replace it? No, why? I've already got it there. So I can open 3D Paint and open open browse files, downloads, Arduino case. It's not what you turn. 3D view. Oh yeah. This is not going to let me show what I want to show. The other night when I was doing this, I was able to rotate it and turn it around with my cursor. And I guess, haven't figured out exactly how to do that. My point is that the STL file that's created here is a 3D depiction that's used by other 3D programs. There's a 3D viewer in Windows, this 3D paint tool in Windows. I hadn't realized that was that way, but obviously it is. And so, you know, there are other tools you could use for this stuff. So, so that's what I was going to show you today. Questions or yeah.
When you added the post for the Arduino to sit on,
Mhm.
you said you measured from the edge of the Arduino. Did you give yourself the extra clearance inside the box so you had that loose fit that you have now?
On the mounting post?
Yeah, because you said 15 mils from the edge. So, and you said you measured it from the Arduino. So that means it would have been a tight fit when it went in there.
It's a pretty tight fit, but it's not.
Did you allow for that or?
Yeah. I
Okay.
basically took each of the dimensions of the Arduino and added a millimeter.
Okay.
So I knew it was going to move around because I know I'm not going to get those suckers exactly right.
And could you print both of them at the same time, the box and the lid?
I tried and it came up as one object. I don't know the answer, Frank.
Really?
Yeah, you can space them out on the bed. Sometimes you're better off not doing that.
If they're connected like that.
Well, it's not even because they're connected, but the more parts you put on the bed, the more you lose if something goes awry.
That makes sense.
Oh, that's true. Yeah, if you remember that switch box for the satellite relays, it was an orange switch box that was hanging on the wall. Frank designed and printed that, and there's a whole bunch of components inside that box. There's probably another 8 or 10 components that are mounting things like the connectors and the push buttons and stuff like that. They sent me the pictures of that, and I think you probably printed a whole bunch of those little things at once, just because they were little and you could.
Yeah, like some small things will print, in gangs, but I've learned the hard way that you stack a whole bunch of crap on the bed and you get to the 95% part.
And then it shits the bed and you've got to start all over again.
I can tell you the power never goes out at my house unless I'm at 10 to 27-hour print.
It's not worth the chance.
Right.
Okay.
Yeah. Okay. So that's what I've got. Carl, you want to show us? And then Frank, you're gonna do SketchUp if we can make some room at the table for you.
Yeah, we could do a quickie. Al wants to climb today. So.
Okay. Well, do you want to go now then?
Whenever you're ready.
Okay. That's fine. Do you need room here?
Just
Let
I have
me-
a few questions that are
Yeah.
semi-related to
Yeah.
this.
Yeah, Frank, I'll get out of the way.
So you had said that you had used TinkerCAD.
Yes.
Okay. Have you ever had an issue with the sizing not being represented properly on your slicer?
No.
I can do it.
And what slicer do you use?
You're Frank?
I use Cura.
Okay, the utility maker.
Well, Ultimaker originally made it,
Okay.
but the company that made my printer, Lulzbot, they had their own customized spin. Basically, it means all the printer parameters are preloaded.
Okay.
So, I mean, I could take, generic Cura and drive my machine with it, but it'd take a lot more setup.
Okay. Thanks.
While Frank's setting up, something else that John, to amplify something John talked about with printing to an SD card, if you want the convenience of being able just to dump from your printer, from your CAD program on your computer to the printer, there's a device that uses the Raspberry Pi and you can build it yourself. It's called OctoPrint.
Yeah.
OctoPrint talks directly to the printer. It acts as, for the old network guys with, network printer experience, it creates a printer spool or a spool queue so you can dump things to it. Plus, it also supports a webcam. So you plug a webcam into it, and now anywhere in the world you can call up. OctoPrint has its own webpage. You can be anywhere in the world and call up your OctoPrint and watch through the camera and see what your printer's doing. So you don't have to sit there and babysit. John did the same thing with adding a webcam, but he had to use some other bits and pieces to make it work. OctoPrint gives you everything in one.
That's all online, Mike.
Yeah, they do have an app, an iPhone app that you could use to get to it.
Something I use a
And the
lot.
OctoPrint
If you like to
also
modify
has a slicer built into it, so you don't even have to. You don't have to dump G code to it.
So, like,
You
right
can
here,
just dump an STL to OctoPrint. It'll
I
slice it.
extruded this.
Yeah,
The
it
wall
even has a
do that.
terminal that you can just send G
So
code
you
down.
modify
Yeah. So OctoPrint.
parameters.
I'm not in a hurry.
Wall height
You
from
can do that.
I don't like him being on the tower.
It depends. If you're doing like some fine tuning
I
with
can
your G code, I would do
But
it
you
on
can
the
change it here. And
the
it'll,
slicer on your
anywhere you
computer,
use
and then just send the G code
Yeah,
file to
yeah,
the printer,
makes sense.
rather than
so you're
relying.
giving variable names. It
The
works out
slicer in
easier.
OctoPrint's pretty generic,
So you kind of plan them up front.
where you can
Yeah,
use
yeah,
something
So I
that's
typed
specific to your
in,
printer, and it gets
Arduino,
it's an opportunity to head off.
Arduino length.
Yeah, a feature that I like is that you can go to a tab and it'll tell you what the print head is doing at any given moment. Like it'll try to track it in real
I don't know
time.
if
That would be nice.
make it a
And it'll
permanent
show
variable
each
or-
layer as it's doing it.
Also with the slicers, one feature I didn't start utilizing till recently that has really saved me a lot of grief. Most slicers will have like a virtualized cartoon showing the print head movement and the layers as they get built. So you can see, like, I've recently started playing with changing colors in the middle of a print. Well, this way I run the print ahead of time and I can see which layer I have to tell the printer to stop at so I can change print filament. So that's part of the, well, at least Cura has that. I'm sure the other slicers that are based on Cura have the same feature. But you sit there and you can run it, and you run it way faster than real time, which is nice. But you can sit there and watch how the printer is going to execute the print, and it's really good if you got a complicated print that's going to take a long time to run it through and look at like transition stages to make sure that you can head off a print failure when you see, oh crap, this isn't going to work because the print head's moving too far over. So you can visualize things like this before you actually commit to printing them. So that'll save you over a course of a year. I'm sure it'll save you several spools of wasted filament, and landfill stuff.
Mine. Let's move that back.
I'm gonna steal a monitor.
Yeah, yeah. When you're ready, go ahead.
All right, this is a program called SketchUp. I don't remember who originally started it. For a little while, Google bought it, and they had made it available for free. So in the early 2010s, this was quite popular in the maker community. It's very good for artistic type work, conceptual work, architectural type stuff. It's pretty good at that. Kind of just put it out here up front. John showed you Fusion. If you're interested in 3D printing, any type of machining, lathe work, mill, CNC, laser cutting, flame cutting, water jet, stay the hell away from SketchUp. Use Fusion, OpenSCAD, FreeCAD. Any of these tools are way better choices. This SketchUp tool is great for like what I'll show you, which is designed for the VHF room. It's okay for figuring out dimensions and conveying what a piece of furniture is going to look like. It is horrible for real mechanical drawing, and it's that way for a number of reasons. One is that everything in SketchUp is defined as facets. So there's no true circles, there's no true arcs. It's also not parametric. If you draw a cube that's 3 units by 3 units by 3 units, and you want it to be 5 units instead, you have to start from scratch. With better CAD programs like Fusion, you can go in and you can clicky and change the 3 to a 5, and the whole thing grows. And there's some real powerful stuff in Fusion and all the other more professional tools where if you outline a series of holes in a panel, you can reference them from an edge, and you can change all those with parameters. And the same thing with a program like this, SketchUp, if you want to move those holes, you first need to repair them in the drawing, and then you need to redraw them. It's a matter of using the right tool for the right task. So this, John had mentioned this the other day. This is a view of where we are hoping to go with that room. If you look in there, you can see we're about halfway there now. We still need some furnishings. I use this program to do layouts like this and to do furniture design and things of that nature. I do use it to design things that are 3D printed, very much to my dismay. I don't get the results I want. Things are much more difficult than they need to be. The problem is that the mentality for this is very much different than the mentality for something like Fusion. So
is this being exported as an STL?
yes, you can export an STL,
but it's not native in STL.
No,
Okay.
it's a plug-in in order to generate an STL
Gotcha.
file.
Okay.
The ways that things work are completely different, and trying to move to Fusion has been, a several year battle, and I just can't do it. So that's why if you're serious about designing stuff for any type of CNC process, don't make the mistake I did. As you can see, you can get fairly easily and fairly quickly some reasonably photorealistic designs. I'm not an artistic person by nature, but I can represent things as rectangles pretty quickly. If I'm building a project, I will do things in here to scale in order to fit them in a box, for example. So there's a rotator controller, I think it's back in the HF room, that I built a couple of years back. It's based off the K3NG software. It runs on an Arduino. And I wanted to get this thing into the most compact enclosure that I could. So I roughly modeled all the components in the design, right? And I was able to then place the parts into this box and see that, yes, indeed, they would all fit. I could then take the front, do a parallel projection and print out a 1-to-1 template, which I then glued on to the front of the enclosure and used it to mark all the holes for drilling. I followed the lines to mill out the hole for the LCD. Did the same thing for the stuff, walls in the way, the stuff on the rear, in order to lay out the holes for the barrier strip where the USB port goes through for the Arduino. So, if you haven't gotten it yet, this CAD stuff is very powerful and can make difficult jobs quite easy. A thing that I do quite often with 3D printing is if I have a complex series of holes to lay out or something that I need visual, really to look good visually, I will 3D print drill guides and strap that to a piece of aluminum or plastic or whatever it is and go over to the drill press and go to town. And you can wind up with, great looking parts without hours sitting there doing, layout work with a strap.
Can I say something, Frank?
Yep.
An excellent point for that. Frank had mentioned to me that if I want one made, he'd make it for me. One of the things that you'll see in some of the equipment I have in the back is that I will typically drill a series of holes in a pattern, make a grill for a speaker that's behind a panel on a piece of equipment. Well, to center punch all those holes individually and accurately, and then to drill them all in the drill press is tedious. A drill guide for something like that is excellent. And with the drill guide, you can avoid having to center punch it. You can avoid misalignment even just a little bit because everything will go right where the drill guide places it.
And one really good example of that was the satellite antennas, where the satellite antennas had a bolt going through where they could be either horizontal orientation or vertical orientation. That's not where you want a satellite antenna. You want it like this. So that would have basically meant drilling a hole through a piece of aluminum pipe, which is not easy to do. So Frank basically printed a fixture that went around the pipe in the dimension of the pipe with a post that went into one of the holes that was already there. So it would perfectly align. And so here you've got your post. Here at exactly 45 degrees, you've got a hole. And it perfectly aligned with 45 degrees. So that let us take our satellite antennas and orient them in exactly the right polarization.
Yeah, that's an easy job to do if I can take it home and I can set it up on the mill. But I can't take an 18-foot long
Right.
Yagi home and set it up on the mill, right? But I could design a two-piece donut that went around and keyed off the existing holes and gave us the new hole locations. We were able to drill them by hand in the field and come up with a very acceptable result. So that's a great application. But back to this, you can see we've modeled everything, the desktops, the strips on the wall that hold the copper ground bus, the locations of the outlets. We can look up dimensions of the equipment for this. For example, some of the grant money has been used to purchase this equipment for the what will be the new VHF station. And up top here, we see the Q5 signal transverters for 2 meters through 1296. So we can just roughly model rectangles based on the size and lay them in the room and see what fits. Same thing with these linear amplifiers. We can model the rough sizes. We can get an idea of how big the cabinetry needs to be. As a result of this, we were able to shrink the depth of the desktops significantly, about 8 inches, which doesn't sound like much, but when it's 8 inches on each side of the room, that's 1.5 feet. Combined with just having the ability to do some custom stuff, this has bought us the ability to add a third operating position to this room and pick up additional floor space. And this is all made possible because of CAD work. I'm trying to lay this out, otherwise, I don't know, graph paper, maybe cutting out pieces of cardboard to represent furniture. This speeds up the process immensely. You could go from 0 to what I'm showing you inside of an hour without too much difficulty. So just kind of give you an idea of how this works. Everything in SketchUp is based upon the idea of extruding a shape. So if you wanted to build a cube and it was going to be again, 3 by 3 units high, you would start with a square on the ground that's 3 by 3. And it could be inches, millimeters, microns, whatever floats your boat. All the CAD programs will support that. And you want it to be 3 high, so you go up here and they call this the push pull tool. And you grab the face and you click on it and you bring it up. And you want it 3 units high, so you hit 3, you smack the enter button, and now you got a cube 3 by 3 length. You want to put a hole through the middle of the cube. You can, all the tools have this, the ability to pick up an inference. You can find like the end of a line, the end of a shape, the midpoint of a line or a shape. You can start there. And now you can place a circle, and we'll make this, 1.5. Too much. Let me try that again. We'll make it 1, a radius of 1. And you want to blow that through. So again, you take the push-pull tool, you pull it through, and you've got a hole through your cube. That's basically the entire principle of how SketchUp works. And you can learn to use this methodology to create pretty much any shape. What you'll see here is, if you can see it on the screen, this is one of the major drawbacks to SketchUp. You see this circle is a faceted shape. And you can increase the number of facets to get closer to a circle, but the smaller the item, the less facets you can have. So when you're working on something that's, the size of John's case, doing a fillet or a round over on an edge, you might be limited to 3 facets, and that's not very good. It does not give you the smooth result that you could get out of something like Fusion. So, that's pretty much the gist of it. Anybody got any questions?
Now you're using a program. I was online. Is that the paid version? Because it looks like the free version.
This is actually 2017, which is the last version. When Google sold it, they sold it to Trimble, a GPS company. And this is the last version that they released before they forced you on the web. And I hate web-based applications.
Yes, that's what this one is.
So this does what I need. I know how to use it. It works for me, so I stick with it. I don't need to be online or anything like that. It is downloadable online if you wanted to play with it. The web version, like Lenny said, is there. It's available. It's free.
Cool. All right. Thanks, Mike. Carl?
I'm jealous. Get
But you're the
comfortable.
professional.
Yeah, but you guys, you're doing things that take me a long time to do. That extrude, well, I'm going to extrude some stuff, but you'll see what happens when I go put a hole in an object here. Let me figure out how to do that here for a second.
You know how to do that?
Let me see, Chrome.
Chrome.
Back, you can move that in. More room.
Thanks.
Thanks, Frank.
Whoa. Hey, that don't work. It's okay. All right, so, John, I'm in Chrome, and then what? CAD,
Yeah.
name room TV
Yeah,
available.
but make sure before you do that, click on your whole desktops instead of just doing. Otherwise, it'll just be
On the sources.
Yeah,
Oh, wait.
right below it.
Hold on. Oh, okay. CAD.
Sources. This is the
Okay.
CAD screen.
CAD screen.
And then click on the main room TV.
Pen have a magnet in it, or
Just come up and sit down and
So
work
I
with them.
just minimize it now?
It's
Oh, yeah,
inductive
just
charging
minimize
inside the
Chrome
pen
and go back
charges.
where-
oh, okay.
Oh, okay. I'm talking about AutoCAD.
And
I've
then
been
when you
using
do
it for about 20
It
years
tells you
now.
at the top
Almost every version
what the
started
state
with
of
DOS
charge is.
through
Okay.
2023. This is
No, like
version
if you had an
2013,
iPad, you wanted to
which is
borrow
one that I own.
pencil,
It's
you
probably the last one you
clip
could
it on your
buy.
iPad real quick. They would
After that, it went
lock
all
it to your
subscription just like
iPad.
everything else.
And then when you're done, you can hand it back to me, and I do that, and it's back on mine.
It's going to be a little slower than those guys because those guys got really cool tools. All right, AutoCAD always works in 2 modes. You're in model space or paper space. Model space is life size and realistic. Paper space is a view or a photograph of model space. That's a very,
2-dimensional?
no, 3-dimensional.
Okay.
So we're all sitting here. If I took this photograph, you would be in the photograph. And if you got up and went away, you wouldn't be in the photograph. But you can set up multiple cameras. So if I'm showing a cabinet and I add a shelf, it'll be added in every view you can see it, which is very powerful for showing things, multiple things at the same time. So I'm going to do something that John did. I'm going to draw your little box that you did, your little shelf. And I'll show you how long it takes me. So I'm just going to do something with, hang on, I need that one. Okay, comes up. Okay. Need that page. Okay, so I'm going to go 1 inch over. I start at a point, I click to the right, I type in 1, draw the line 1 inch over. I'm going to draw one that goes down 1 inch over. I'm going to go 6 inches over. Up 1 and over 1. Okay, this is a basic shape. This is sort of that shelf you did.
Oh, this is a shelf.
It's that little shelf you did.
This is the Arduino box.
Yeah.
Okay.
Oh, okay. No, the one that holds it, isn't it
Yeah,
underneath the countertop? Okay. How thick was your shelf, John?
2 millimeters.
Okay. I don't know what that is, so I'm going to use 1/8. So I click on it and I hit offset. Sorry, I can do it in my head, but it's just going to take too long. So that's 0.125. Now I have a 2D object, a pair of 2D objects, and this is important. This is a linked line, or it's called a polyline. You see how every segment's lit up? If I explode it, and that's very important to know because I can explode it. Now it turns into individual sections, which I don't want in 3D modeling. But you might want it in a 2D drawing if you're trying to show something specific. So I'm going to weld them all back together. Okay, so now we're back to being one line. All right, so I still have your basic shape. I got to join these little ends. There we go to you. I put a little end on that. Repeat over here. Didn't want to do it. Okay. So there's your basic outline of your box. The next thing I have to do, I have to join them all together. Right now they're not. See, there's the upper, the lower, and the little sides. These are all separate lines. I need it to be one solid line. Enter. There we go. Now I have that. The join doesn't really do me much. Good. Turn it on the side. How deep is that box?
Let's make it 100 millimeters.
Okay, it's about 4 inches.
Yeah.
Sounds good.
So I have my basic shape, and initially what I did is I had to decide what view I wanted to start with. Looking down at the top, I really couldn't draw it. So a profile in this particular case is what I want to do, and I'm constantly thinking in three views. I'm always looking at mentally the front of something, the top of something, and viewed from the side. So with those 3 axes, I can basically see everything I want. You need more for more complicated stuff.
That's a great feature. Any of these CAD tools, 3D printing is all metric. The lead screws are pitched in metric. The nozzles are a metric size diameter. But my brain works in inches.
3.8.
So you can draw in inches if that's what's more convenient. And you can export in millimeters.
Yeah.
You don't have to do the conversion. It'll do it for you.
Yeah, he's right. Actually, I drew for probably 18 years in decimal English and then had to convert to millimeters. So 25.40005 is the scale factor up to go from inches to millimeter, and 0.039370074 is the divider. Well, I used to do it on a daily basis because the guys want to see English, but the machines want to see millimeters.
Yep.
So I was doing both, drawing and programming CNC equipment. Back to my little thing here. Okay, John said it was 4 inches, right?
Close enough.
4 inches. There we go.
Yeah, so do I. I even have ones that had.
Now I have
because
the basic tray. And this is where it's going to get a little slow now. Those guys can put holes in way faster than I can. Right now, I was looking at the side. I'm going to look at it from the top. Now I'm at the top, shrink back a little bit so you can see it. So now I want to put 4 mounting holes. Those guys can draw a circle and say go through. My process is a little bit more. I selected a circle. I'm going to use 0.125 1/4 inch holes. And it's faceted. I can't on the screen, but in AutoCAD, everything you draw is an actual circle or a radius, or there's no facets unless you want to draw one. So in that respect, it's a little bit more friendly than that. Now I'm going to take this object, and where's my circle? Okay. I'm just going to extrude it some random length. Okay. So now I have what looks like a bar. Cylinder. Let's see, this will show it better. You can see the cylinder a little better. Actually, if I make it blue, by the way, I make it blue, right? Okay, so you can see it a little better on the screen. I'm going to go back to the top view, and I'm going to move it in. Since I know that flange is 1 inch, I'm going to do this and move it over 1/2 inch. You can already see how long this is taking compared to what those guys did. Then I'm going to move it down 1 inch. 1. Okay. Now the neat thing, I'm going to turn this back on. This is called a solid view. This is a wireframe view. I use this all the time. It confuses the hell out of people because I'll look at 3 cabinets turned on an angle and I'll see a whole bunch of lines, but I'll know which one's which, and that comes with experience. All right, so now I got this one circle. What do I do with it? Well, I like it to be symmetrical, so I'm going to mirror that one using the center line and mirror. Sorry guys, this is not set up the way I want it. Completely mirror over. Okay, now I have 2. But we want 4 mounting holes, so I'm going to mirror it over the other axis. Now I got 4. You can see how long this is taking compared. You guys draw a circle and say hole. I wish I could do that. So now I want to see it from the front. I'm looking at it from the top. I want to see the front. Take the front, drop it down. Some random length, 1/4 inch. Doesn't really matter. Now this is the part I like. This is where the hole actually gets drilled. I'm going to subtract from this these. Now I have my 4 holes. So I have to draw what I'm essentially making like a punch, and I'm punching it. They're just drawing the punch and saying go through. I have to actually create the object and then subtract one from the other. It's a little time consuming. So in a lot of ways, what they're doing is very useful. Way more useful than this.
Let's learn the basics.
No, I don't want
The
it.
camera, you
Sorry.
That's okay. So that's a basic object to draw. If I wanted to, I could export this as an STL and that'll come out just the way I did it. I've only done one object. I'll show it a little later on. What's powerful about this is I'm in paper view right now. So this is a piece of paper I'm eventually going to print this on.
Now to expand a little earlier on what I said, or expand a little on what I said earlier. See, Carl drew the bracket and the holes are about 1/2 inch from the edge. If he said, "Oh shit, that bracket really should have been 6 inches long instead of 4 inches," in a parametric CAD program, if he referenced the holes from the edges, he could now expand that bracket to any length, and the holes would remain 1/2 inch from the edge.
Yeah.
With something like what I'm using, you have to remove them holes, then expand the bracket, and then put the holes back.
I could either expand the edge and then move the holes. This is not parametric, so I have to do it by hand as well. It's not any faster than.
So that's where the power of something like Fusion or SolidWorks that John's using comes in. When you start getting into really complex shapes and you realize early on you made a boo-boo, you can fix it very easily in a parametric CAD program. Whereas with something like SketchUp or the old school AutoCAD like Carl uses, it's much more painful.
He is right about painful because it can be painful. It really just depends on what your goal is. All right. Right now I'm in paper space and I created photographs of the object, but I created all of the same object or all of the same views. So now I'm going to go into model space from papers. Where is it? Oh, there it is. Paper. Okay. On this view, I want to see it viewed from the top. This one from the bottom. This one from the right side. Okay, let me make this one from the. Okay. So there, right now, model. I have 3 views. And if I printed this on paper, print preview what it would look like, that's what it would come out. Of course, I put labels under it, isometric, front, top, side.
Did you put the dimensions on it?
Yeah, gonna do that next. All right, right now, I want to point this out. If you look at this view right here, oh, my mouse is, wow, you can see how it looks kind of semi-transparent. That's because I'm using, this is called wire view. And what I'm doing is just seeing the edges of the object. It is a solid, but I'm only seeing the edges. So I'm going to convert this view, modify properties. I'm going to convert this one to custom scale. As displayed, I want to make it legacy hidden. Okay. Now if I click on it again, that's what it looks like. All the wireframe went away. So you'll see what you could see and not what you couldn't see if you physically had the object in your hand. So John asked for dimensions. Let me put them here. All right, I'm going to dimension this. Now this I have to do manually where I understand you have automated tools. There's 4, 3, and I could measure the land height. Basically a side view. And normally I put labels on it. Let's see overall. Okay, so now that's pretty easy. You told me create something, show it, and dimension, which are basically the 3 things you want to do. You have to create your object. I have to show it. You guys don't. Well, you're going to show it because you're going to print it. And then for me, I'm going to print it on paper. You're going to print it in plastic. So if I have this, I go back and just do one little alteration. Long model space. They're all over the place on the paper. Oh, I could do it in here. All right, let's say I want to, in the forward view, do a cutout. I'm going to extrude that box, whatever it is, 2. Now you see the boxes you see how it appeared everywhere? It's not here, it's also here and here. I'm going to go over here. I could go back to that black space and do it, or I could just do it right here. It's just as easy. I'm going to subtract this box, which would give me a notch. If I spent a little more time, I could have made my notch and do it. But this is the way I can do it while I'm working on it.
It's like the same cylinders you had to create the holes.
Yeah, this one I had to create a block as big as I want it, position it where I want it, and say, okay, this is exactly where I want it. Subtract. So this is a very basic drawing. This is a part drawing, and those 2 programs that they're using, they're very good at part drawing. This is not the best program to part. This is the best program for assemblies. And I'll show you something I'm working on now in work. A gun display, gun cabinet, actually. This is probably one of the more complicated 3D printed. Oh, this is a 3D printed part I made. Go away. What this is a white bracket. It was about this big. I didn't bring with me. And what happens is a gun goes inside and it holds it on display. So it holds a handgun sitting upright. This is nothing more difficult than what I did before. A few more curves. I can make it solid. That's not pretty. That's pretty. Okay. And again, I can rotate this around, look at it. No magic to this. Where the power of this one comes in is, let me open the drawing that this is actually a child drawing. And I have to go where it actually went was the EOTech gun cabinet. Okay, this is for a company called EOTech. They make gun sights. And this is a display it went in. See what it looks like. That's comprised of steel, TV monitors, graphics, and if you look right down here, I can zoom in on it. There is the piece that the guns go on. That panel lights up. That's white acrylic. There's LEDs underneath. So that panel actually glows while the gun's sitting on it. This is what I did. This is my full-time job. So this comprised a lot of parts. Each one drawn one at a time.
And then you just put them together.
I put them together. Yeah, here's another page with dimensions on it. What else do we have? This is one of the blowouts of the steel frame parts, and these are all modeled. Those are actually tubes. They're not solid rods. And I do that because in AutoCAD, I can grab all the metal parts and say, tell me the mass of it. And steel tube, I go, oh, mass is so many pounds per cubic inch, whatever, and pop a weight from it. And I do that for all the wood, all the steel, and the plastic, and then I add a few pounds. But that can get you dangerously close to what something weighs. If the more accurate you draw it, the more accurate you can get information out of it.
So before you ever commit to a physical object, you already know, hey, this is going to require this type of shipping container because it weighs X.
Exactly.
Very cool.
Exactly.
That's neat.
So this is kind of an example. I'm trying to find the tab for, oh, model space. My model space tab disappeared. Thanks a lot. Oh, no, wrong one. Hang on. Laptop A.
So when you're designing something, then you would say this is 3/4 inch aluminum or something
Yeah.
like that.
I'll take a box and I'll click on it and I'll run up 2 inches and over 2 inches. There's 2-inch OD tubing. Then I'll do an offset of an 1/8 inch coming inside. I'll extrude the outside box a foot long. I'll extrude the inside box like a punch, 2 foot long. And I'll say subtract the inside from the outside. And then I get a piece of tubing.
Like when you did the original SDR holder,
Yeah.
you didn't tell it what it was made of.
No, I don't have to. That's for me.
Sometimes
That's
you do.
For me at the end when I draw this page somewhere up here. There's probably a notation that this is all.
Or is it assuming that it's made out of something?
No, it's not assuming.
Okay.
Remember, in this, I'm having this fabricated at a shop outside. This part's not 3D modeled, and I will tell them this is 20 gauge cold rolled steel, powder coat black. So that's just the label I put on it. The software doesn't care what you're making it out of.
But how does the software know how much it weighs?
Because I can click on one of these tubes, and I'll show you that. I can click on one of these. Oh, there's the tab. I was trying to get on one of the tubes. Here are some of the parts it's made out of. Actually, this is all the parts it's made out of. Wow, this is just not being friendly today, guys. I don't know why, but welcome to computers.
There's a lot. Yeah.
Come on. I want my isometric view and it just disappeared. Oh, there it is. Boop. There we go. So that's a lot little. Let's see. Which one is the full cabinet?
15, 20 years.
Okay, here's the full cabinet.
Back in 2000,
Shake it a little bit. Okay, so how do I know? I want to know how much this steel pipe weighs. I click on it and I type mass prop, MASSPROP. I haven't used that command in a while. Oh, it wants it first. There's the properties of that tube.
But at some point, you told it what it was made out of.
No.
Well, how the hell does it know?
It doesn't care. It doesn't care because when I print a nice sheet and I give it to the fabricator, it said, here, it's 20 gauge tube painted black. I tell him what I want it made of. When I want to calculate the weight, I look at this and I say, oh, this has a, where is it? The mass is 47.9804 cubic inches. So I go to Google, I say, how much is carbon?
So you're figuring out the weight. It's not figuring out. I thought it told you how much.
No, but it's telling me the exact mass of it, the volume, if you will. So it'll say wood's 2 pounds a square foot. This will tell me this is 4.6.
But you're doing
more. Yeah, that's why I said more advanced software.
I missed that point.
Yeah, more advanced software can tell you that.
So,
questions so far? I have one more object to show you guys.
Will it spit out a bill of materials?
No, this is not. That's called BIM based software. And AutoCAD Inventor will do it, and SolidWorks will do it. And those really two are the heavy hitters. AutoCAD's kind of going by the wayside because about 15 years ago, SolidWorks came out, which is a lot like Fusion. Fusion, SolidWorks, and Inventor are all like in the BIM group, where you can natively get information, parts, how many screws did you use, did you have in your drawing, ad infinitum. AutoCAD is not. The reason this still has value is in the trade show industry where I work. There are plenty of guys who'll just come down, sketch out a booth, they'll create all the parts, and then I'll turn around, take those parts, and write CNC code for it. It goes out to our CNC. So I don't need the fancier. This thing can do so much more than I'll ever learn how to do. You know, I learned to use my
software's like that.
Yeah, I learned my 15 commands, and I don't care about the other 450. All right, one more thing I'll show you guys, and then pretty much they saw me basically how to build something, show it, dimension it. This is a lot more complex. This, I really hope this one comes out. I just worked on this week. This is for Sony Corp for CES 2023. It's a gigantic light bulb.
Hope that's already made because CES is in like 2 weeks.
We got plenty of time. Let's ask the sales guy. He'll say, "Oh, we can do it, sure." This looks kind of weird. This is a light fixture. It's 14 feet by 22 feet. So it's basically the size of from here to that wall. It's all LEDs. And this is basically every component in it.
How much RF does it get?
I have no idea. This is an overhead shot of it. Lucabon panel. This doesn't really tell you much. It's telling you it's Lucabon, which is the material it's made of. These are the panels themselves. There are dimensions on it. I'm showing holes. I'm not dimensioning because I will turn purple before I dimension all those holes. I'll tell the CNC. CNC will punch it. If something's wrong, me and the CNC are going to have a fight because you don't have time to do that. And different blow-ups. This is the steel frame. This is interesting. That ring that you see around it is actually comprised of 12 different rings, 3/4 of an inch thick, 1 inch wide. At the length of this room. There's 12 of them, I think. Yeah, stacked on top of each other. This is something the salesman designed, not me. So I take no credit. I'm still waiting to see if it works. A couple exploded. This is an exploded view. This is every part that goes into it. Steel frame, the white Lucabon panels, and they're just white panels you put to create a ceiling, and they're very lightweight. These are all the wooden rings it takes, and this is the metal ring at the bottom. It's like a horseshoe, just to keep it together. They're going to stretch fabric and hope it stays flat. So you can imagine how hard they're going to have to pull on the fabric to keep it straight. Tube steel frame. That's just another shot of it with some dimensions there. The one thing that's really interesting, the guy was pretty smart who thought of this. Let me see if I can get to it. Rotating. This thing has to be assembled the size of this room upside down because the guys have to reach in and put the lights on it. Then they have to stretch the fabric. Then they have to turn it over. How do you turn over something that's 14 feet wide without smacking it on the ground? This is what the guy designed, and which then I implemented. Basically, it's upside down right here. There's a little narrow section here, but I'm saying the fabric's on the top. Actually, sorry, it's long. Get rid of all the crap. Okay. Next, we're going to bolt these 4 legs on right here. There's 2 here and 2 here. And then I'm going to attach a crane right to this point right here. There's 2 of them. We're looking at 2 like this. So we're going to lift it up and then roll it over, which will then sit on these 4 caster wheels, which they'll roll around, attach all their lifting points, and then they'll release the wheels and lift it up into the air. And it's going to be a gigantic white light bulb. It has 1,284 LEDs, modules. Each module has 3 LEDs.
So you basically had to add that piece to allow it to be turned over.
Yes, it's a temporary bolt-on piece just to turn it over. But this is where AutoCAD comes in handy because a lot of times I drew one part and said, okay, make me the mating part, and I can do that. I can say make sort of like what you can, but not. Yours is a lot nicer to do. And just to finish it off, because that looks kind of weird. Let me see if I have the photos. Overlay photos. Here they are. No, I want a Windows picture back here. I don't know how to do it on here. Okay, this will be about the biggest one.
Oh, wow.
That's a picture of it. I got one more. I think it's a little better, but I don't know how to. Where's the one with Frank? Let's stop a longer shot. That's how long it is. You can see the guy standing behind it right here. Give you a sense of scale of how big this is.
Oh,
Which surprised me because I sit here all day and I draw on a screen this big and I go out and I'm like, wow, I didn't know it was gonna be that heavy.
And you go to a show and you don't think of all the crap that went into building that thing that's hanging up
Yeah,
there.
because
and
you're
then
just
you-
focused on the
That's right.
neat little
all,
thing
all
that
it is light. You know,
Yeah.
I mean,
So that's
you're looking at the gadget.
Steel frame, wood rings, these white panel Lucabon panels, a
Would that-
gajillion LEDs,
Oh, yeah.
9 power packs.
and a
almost
tractor trailer to
13
haul it in.
Yeah, and guess
Yeah,
what?
probably
After the
trashed.
show, in the dumpster it goes.
So it just.
Oh, what a waste!
And that's very common in my industry.
What a waste!
One and done. The industry I came from, I built thousands of one. So if you like this cool display that holds the mouse, I might build 5,000, 6,000 of those. Here, it's hundreds of one of a kind. Anybody got any questions about how AutoCAD is and how you absolutely don't ever want to get it? Avoid it. What this is way more powerful in certain ways than the two programs these guys use, but they're getting results way faster than I ever could. So really the tool it's just like matching the tool to the thing. And I could never get Fusion. I couldn't do Inventor for the same reason I can't do
Yeah.
Fusion. I can't wrap my mind around the way it works because I'm on the other side of the track.
Right.
I'll tell you this, having used 2D CAD software for many, many years
Mhm.
and trying to get myself into the 3D mindset to work with
Mhm.
Fusion,
Yep.
I'm forcing myself to do it and it's starting to come clear to me. It is a huge steep learning curve for somebody who has been using 2D CAD software for a long time. I think people who have not used CAD software at all have a better chance of grasping it right away because you don't have any preconceptions to deal with.
Yes,
Yeah.
You
that
don't have any bad habits to deal with.
And the problem that I have is I do this so infrequently that I forget how to do stuff in the meantime. I mean, I did a whole bunch of stuff a couple of years ago and I had to go back and watch YouTube videos on Thursday.
Thank God for
So
you.
I did this stuff.
How they do that?
YouTube
That's
University.
Yeah, absolutely.
That's it.
Actually, I have one more thing I wanted to show you, only because I just feel like showing off. Let me see if I can find it of a light. Okay, this is a little project I did years ago where I think I wrote the code for. Yes, come on. Audio rack or the dev? Okay, dev. And we get on the home page. This is just a little desk I wrote. Okay, so you can see it. That's an audio production desk. You notice it's C-shaped, not moon-shaped, for somebody named Carl. You understand? Has a recess shelf for the monitors.
Did you actually implement this? Is this in your den?
This is my shack. I'll
Oh,
show you a
okay.
picture of it when I get to it. I just thought I'd run through some of the things. So like I did a basic drawing, work desk. Here's some like, I probably should have grabbed the PDF. This is kind of showing some parts. See how I got transparent here, solid views here. So I can see through it. A lot of times I could draw a cabinet with shelves in it and you could look and go, oh, look, it's got three shelves in it. Without ever having to pull them out and say, oh, this is a shelf and there's 3 of them. So wireframe, it's called wireframe, and somebody beat me up once really bad. They go, what's wireframe? And the guy said, you mean transparent? I'm like, oh yeah. Wireframe's the name of the command. So I just went with what I got. These are the speaker stands. This is the setup for the speaker stands. These are all the parts that make up the stands. And the leg. Oh, this is something I had to do. I bought legs. Their dimensions were wrong, so I actually traced one, scanned one, and drew it on top of the scan. Because you can import PDFs and say, okay, you could draw right on top of them.
Mm.
And you only need to scale up one dimension to get the scale correct.
Yeah, you can do that in Fusion also. I could take a picture of an Arduino and place it on the screen and then draw around it. I forgot about that till right now.
Yeah,
So I've seen that done, but the question I always had is how do you scale it? So how do you know your picture
You
is?
tell it. So you take the picture and you put it in and you tell it that these 2 holes are so far apart
right.
because you've measured them, and then it scales everything else.
Okay, so
you can actually visualize the box around the Arduino. So on the screen, it looks like this. It doesn't look like this. It looks like this.
One of the tutorials that Autodesk has for Fusion 360
Nice.
That's
has
the
you
actual,
taking
that's
a
my
photograph
actual,
of the box.
that's my shot.
Put in a center line, a vertical center line.
Do
Like that.
live recording,
Then create one half of it.
podcast editing. Which,
with
by the way, I got a file
points
for you, John. Your
to give you an
contact
outline
is
of the
like
bottom.
your audio sucks. So
Then
I decided
refining it at the top to a
post-process
certain
it, make it a
size,
little louder
refining
and
at the
clearer
bottom
for
to be
you.
flat.
Okay. So I'll get that.
And then you
All right,
close
good.
the sketch and
Cool.
you take
So-
that
That's cool.
That's it for
outline that
me.
you drew and you
Any
revolve
questions?
it to make it into a full.
You're obviously in the
round
audio.
Yeah.
To make it into a
A
bottle.
little
Okay.
bit.
Then you
Yeah,
hollow out
you
the
could
inside
say
of
since
it
I
and
was a
you've got
kid.
a bottle.
It was my other passion besides in
Pretty
electronics.
amazing.
That was always my go-to.
Okay.
That's
Gotcha.
why I just love the audio.
That is a beautiful sound.
That's,
Yeah.
that's nice.
Thanks.
Oh my God.
Now,
At the end of recording, and then we can just
Okay.
take it out. That's fine. You guys
This is
continue
proving
to
to
talk,
be-
but this will be the end of the
All right,
of what'll be on YouTube.
Here's-
Let's kill
This
this
is
one.
proving